Alright folks, welcome back to another exciting Math Notes video. Today we're going to do a little review of trigonometric ratios. This is section 2.1.1. So we'll just go through this writing real fast here. There's three trigonometric ratios, let me zoom in on this a little bit, that you can use to solve for the missing side length and angle measures in any right triangle. You may recall that from last year. We had sine, cosine, and tangent. In the triangle below, when the sides are described relative to the angle theta, the opposite leg is y and the adjacent leg is x. The hypotenuse is h, regardless of which acute angle is used. And so what they mean by that when they say regardless of which acute angle is used is what the value of theta is for that angle, because obviously if we picked up an alpha right here, that would change what was opposite and adjacent. So when we last talked about this, you probably recall learning Sohcahtoa. And just to remind everyone what those stand for. So stands for sine of theta equals opposite over hypotenuse. The ka part was cosine of theta equals adjacent over hypotenuse. And the toa was the tangent of theta equals opposite over adjacent. So it's sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Let's do a quick example here, and then I'll have you guys do one. So when we're trying to solve one of these, we always have to have two out of the three variables, right? So we can only have one unknown. So let's say that we're doing a sine problem. And we start with a triangle that looks like this. We have 67 degrees there. We have our right triangle right here. So when I do these, the way I'm going to start off is I'm going to circle my reference angle, which is 67, and I'm going to label my missing sides. So I know that this is opposite because it's furthest from the 67. This is going to be adjacent because it's next to the 67 and is not the hypotenuse. And then finally this is going to be the hypotenuse. So let's say that we know that the hypotenuse here is 17 centimeters, and we want to know what that value is right there, the y value. So I know I'm going to use sine because I have opposite and hypotenuse, which is the O and the H part of the so. So my equation is going to look like sine of 67 equals y over 17. To solve that now, I'm going to multiply both sides by 17. And we'll switch this around so that we have y equals 17 times sine of 67. You want to grab your calculator at this point and figure out what the sine of 67 is. Give me 1 second. Okay, I'm back. So we punch in our calculator. First we make sure we're in degree mode because these are degrees. So sine of 67 is 0.9205. And when we're doing sine, cosine, tangent, we want to go out to 4 decimal places there because that can make a difference in our answer. And then we'll round at the very end, okay? So we're going to take 0.9205 times 17, and that's going to give us 15.65. So now I'm going to round to 2 decimal places, and this is centimeters. So our opposite side here is 15.65. If they had asked us to find the adjacent side, we could have used, for instance, cosine, Or now that we know two sides, 17 and 15.65, we can use Pythagorean theorem. Let's do one more where we have to find an angle. So I'm going to draw another right triangle like so. And we're going to solve for theta this time. And let's say that we know that this is 14 inches and this is 18 inches, and we want to solve for that theta. So let's go ahead and circle our reference angle. In this case, I'll highlight it, label my sides. So across from it on the opposite side of the triangle is opposite. The longest side of the triangle is the hypotenuse. And adjacent but not the hypotenuse is, well, adjacent. I usually find it's easier to label opposite and hypotenuse first, and whatever's left over is going to be adjacent. So let's see what we have. We have data. We have a number for the adjacent and for the hypotenuse. So that should lead us to cosine right here. Because we know adjacent and hypotenuse, and we're going to try to solve for that theta. So we're going to write it like this. Cosine of theta equals adjacent over hypotenuse. So that's 14 over 18. Now recall that to find an angle, we're going to use our inverse trig functions. So theta equals inverse cosine, and that's usually the button right above cosine on your calculator, of 14 over 18. So let's quickly solve that. 14 divided by 18 is 0.7 repeating, so we want the inverse cosine of 0.7778. We'll go out to 4 decimal places, which is going to give us 38.94 degrees. So we know this is 38.94. If we wanted to find this angle right here, we could subtract 38.94 from 90, because we know that the two acute angles have to add up to 90. So then this would be 51.06 degrees. Those are both degrees. Okay guys, so in parting here, let's do one for you to do, or give you one to do rather. Weird phrasing. Let's take another right triangle. Let's say that on 1, we know this is 38 degrees. We know this side is, let's just call it 6.5 centimeters, and we're going to say that this guy over here is 3 centimeters. Oh, no, we don't want to give you that. So let's have you solve for this side down here. Okay, and 3 centimeters is just a guess, guys, so don't go using that for that. All right, so find x there. And then in your second problem, we're going to have you solve for an angle. Another right triangle. You're going to solve for theta this time. And we're going to have sides of 7.2 and 4.6. And both of those will be in centimeters. So give me x, give me